Hello, welcome to ME 510, Economics and Policy of Engineered Energy Systems. This presentation is part 3 of our three-part series on the future of natural gas, a report by the Massachusetts Institute of Technology. This presentation will focus on a policy scenario described in the report by the MIT. MIT looked at some projections of natural gas production and consumption across the different regions in the US. Essentially, what you see in this graph is the current net imports for each of the regions in 2006. For example, in the North Central region, we have in 2006 a negative 0.8 net import of natural gas. The projection is that by 2030, the North Central region will be exporting even more natural gas because of the shale gas revolution that we've talked about, up to the tune of minus 1.9 trillion cubic feet of natural gas. A lot of this growth in exports are going to be sent to the South Central region and to the mountain region. Okay, now that we have an idea of what the changes in imports are going to be across the region, let's look at what policy actions MIT considered and what their impacts might be on the ultimate production of natural gas. In the report, they looked at two types of scenario. One is under a price-based climate policy, and then the second one that we'll look at is a carbon-based climate policy. The price-based climate policy is similar to the idea of a carbon tax. The notion here is that fuel suppliers will have to pay a fixed amount for each amount of greenhouse gas that they emit when they generate electricity. Based on this type of policy, what the report calculates is that heavy polluters such as coal power plants would see a dramatic decrease in production. Natural gas plants, although they do produce some amount of greenhouse gases, would still see an increase in production, but as we'll see later, it may not be as significant as if there was not a policy in place. Nuclear energy, because nuclear plants typically take a long time to be commissioned and operated, you can see that there's not much change throughout this period into 2045 where we see an increase in nuclear power. Hydro faces a similar condition, similar production throughout this period. We see a very small increase in renewable production between 2010 and 2050 under this scenario. The biggest impact under a price-based climate policy is actually in reduced use, energy efficiency. The notion here is that if there is a carbon tax of sorts, consumers will see higher electricity prices, and that would drive them to use more efficient appliances or to reduce the electricity use altogether. And that's likely to have the greatest impact on the electric sector. If we look at this under a total energy use scenario, not just electric power, but also transportation fuels, what we see is again, coal would not be able to compete because of its high emissions. Oil similarly would have to have lower consumption, both in the transportation sector and the electricity sector. A lot of the decrease in oil consumption will be taken up by biofuels starting from 2035. And we will see natural gas still being used primarily for the electricity sector. However, in terms of the total energy use, this is where we see the most dramatic drop in reduced use of energy. The notion here is that we would go from a near 100 quadrillion BTU energy use to somewhere below 80 quadrillion BTUs, mostly because consumers would face higher prices if they decide to essentially pollute more or emit more greenhouse gases. This slide here looks at the impact on natural gas prices specifically and electricity prices in general. As I mentioned, if there are no policies trying to limit the use of natural gas enacted in 2010, essentially you would see an increase in natural gas prices that follows inflation rates. So it would go from near $5 per 1,000 cubic feet to about $10 per 1,000 cubic feet in 2050. However, if there's a price-based policy that's based on net of carbon, so this means you pay a tax based on the excess amount of greenhouse gas emitted compared to coal, for example, then you'll see a modest decrease in the price of natural gas. And this is because natural gas has a lower environmental footprint than coal. So even though you're still emitting greenhouse gases, because you're cleaner than coal power plants or cleaner than the average grid, you're able to get some tax credits in this case for natural gas plant. However, if the price-based policy taxes for the gross amount or the total amount of carbon emitted, then you'll find that natural gas prices could increase considerably. And this is because suppliers would pass down the prices to consumers in order to pay the government for their emissions. The impact on electricity prices is similar. Under no policy scenario, you see an increase mostly based on inflation and other factors. But if you have a price-based policy, then you see a dramatic increase, almost doubling of the electricity price between a no policy and price-based policy scenario in 2050. The alternative policy scenario is that the government could say, well, we want the electricity sector to have an upper limit to how much is emitted. What this means is that facilities or companies trying to supply electricity would have a quota of how much greenhouse gases they're allowed to emit, how much carbon they're allowed to emit. What that would do is it would allow coal plants and oil plants to continue to provide electricity. There wouldn't be any price effect or penalty on those plants, but the market would not be able to expand by building new coal plants because that would increase beyond their quota. Instead, increases in electricity would have to come from cleaner sources of energy, such as natural gas, nuclear, renewable energy, and we still have a little bit of reduced use. What this scenario does is it allows coal plants to remain competitive. Certainly, many of them will shut down because of their end of their lifetime or because they're no longer economically competitive, but there wouldn't be a penalty to producers for keeping those facilities running. If you look at the impact on total energy use, because there are no price impacts on the consumer, you will see a growing demand of energy over the period listed here. The impact of efficiency improvements and reduced use is much less than in the price policy scenario, but we do see a significant decline in coal use. Oil actually would grow a little bit, and so would natural gas. And in this scenario, we'll see an increase in renewable energy in the early years, but then it will stay fairly steady to 2050. This slide just shows a comparison side by side. I encourage you to read the report in detail if you're interested in policy analysis. I think the report does a good job of describing how the policy scenarios would behave in terms of affecting the electricity sector and total energy use. But what is clear from here is that if you have some kind of price-based climate policy, such as a carbon tax, you're going to see a strong response from consumers, potentially some very strong environmental gains. However, if you have a carbon quota or carbon limit, then that allows us to keep polluting the environment, maybe won't decrease the amount of energy that our community uses. And so those are the trade-offs that you would have to face. Obviously, the second one appears to be more attractive to industry in this regard. That concludes our presentation on the future of natural gas. We'll see you next week.